In example 3, we've got two stunt planes that take off from an airport at the same time. One flies north at a speed of 300 kilometers per hour, and the other flies east at a speed of 225 kilometers per hour. How fast are the planes separating after 4 minutes? Okay, so I think the first thing we want to do is to start with a diagram. So we've got our plane that is flying north at 300 kilometers per hour. We've got a plane that is flying east at 225 kilometers per hour, and I should write that in before I forget. So I'm going to call this y, I'm going to call this x, and the distance between them will be, say, this distance right here. Let's use a different one. So this looks like the ladder question again, but here we are. Okay, so that's the distance between them. And initially, if they're taking off from the airport at the same time, initially their distance is like that, and then their distance is like that, etc., etc. Okay, so the distance between them is really on that diagonal. dy dt, maybe I'll write this down, dy dt and dx dt. dx dt is equal to 225, that's the one that's flying east. dy dt is equal to 300. That's the one that's flying north. And they're both positive because x is getting bigger and y is getting bigger. Okay, so now we need to come up with an equation. And of course, what we have here again is a right triangle. We don't know what this distance is. In fact, what we do know is that it's changing. So I guess I'm going to have to introduce another variable. This is always a dangerous proposition here, because the more variables you introduce, potentially the more complicated the problem gets. Let's go with this because z really does change, right? It does actually change based on x and y. And I suppose we could actually write z as the square root of x squared plus y squared, but let's just see where this takes us. Okay, so I've got my step 1, I've got my step 2. Step 3 is to take the derivative of both sides of this equation with respect to time. So 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, now of course each one of them has a factor of 2 that we can get rid of, and our equation ends up looking like this. How fast are the planes separating after 4 minutes? Well, what we're looking for then is dz dt. Okay, the rate at which the distance between them is changing, also known as their separation distance. Okay, so let's see what we have here. Now we're being asked how fast the planes are separating after 4 minutes. Okay, so let me draw another diagram then. Okay, so here's our diagram over here, and what I'm trying to create here is a separate diagram that shows not generally how the three x, y, and z variables relate to each other, but at this very specific point in time, after the two planes have been traveling for 4 minutes, what's the picture at that instant in time? So we do know that the formula for distance is equal to speed times time. Okay. Now keep in mind that they're giving us the time that is passed in minutes, but the speed is in per unit time in hours. Okay, so what we have here is we've got 225 kilometers per hour times 4/60ths of an hour. Okay, so then that should give us 15, I do believe, 15 kilometers. And then in terms of the plane that is going north, it is traveling at a rate of 300 kilometers for 4 minutes, which is 4/60ths of an hour. And so that would end up giving us 20 kilometers. Okay, so I think if we have a right triangle with a height of 20 and a base length of 15, then we can easily determine what the z value is. Okay, so we can go, 20 squared plus 15 squared equals z squared. So I end up with 625 is equal to z squared. Z is equal to 25. Okay. Okay, so that will be our z in this case. This is our x. This is our y. and this is our x. Okay, so I think I've got everything now that I need to substitute into this related rates equation. So I might as well just sub in as is, and I can rearrange later. So x, I've got 15 times dx dt is the 225. That's the speed of the stunt plane heading east. Okay, plus y, which is 20, times dy dt, that's the speed of the plane heading north. Okay, is equal to z, which we've just determined is 25, multiplied by what we're all after in this particular question, which is the rate of change of the separation between the two planes. Okay, and so basically what we have here is a fairly large number. I should turn this into an arrow. 15 times 225 is 3375. 20 times 300 is 6,000, equals 25 dz dt. Okay, so I end up with dz dt is equal to 9,375 divided by 25, which gives me 375. And since it's a rate, this would have to be in units of kilometers per hour. Okay, now I'll end this example this way. It is actually quite interesting to think about the answer that we got for the rate of change of z and look back at the rates of the individual planes. See if you can determine what the relationship is between 300, 225, and 375 kilometers per hour, and maybe in the future, when you hit a question like this, maybe have a shortcut in your back pocket.